Welcome to lesson number 3. In this lesson, I will demonstrate to you how I detailed 40 years ago, before the advent of personal computers. The lesson I learned then made me the fastest rebar detailer in the United States. Even at my age, I can beat any one of you in detailing with one hand tied behind my back and blindfolded. I'm lying, of course, about tying my hands and blindfolding, but I can honestly beat any one of you in detailing. According to CRSI, Concrete Reinforcing Steel Institute, the average rebar detailer in the United States does 1 ton of detailing an hour. 1 ton an hour. Think about that. It means that if you're averaging less than 1 ton an hour, you are probably just making your own wage. If, however, you are right on and you're making 1 ton an hour, you are probably helping keep your company alive. If, on the other hand, you average more than 1 ton an hour, chances are you deserve a raise. I bring this up so I can guide you to strive to do better than the average rebar detailer. Where does Barline get their work? We get our work from companies who have detailers that can do the work themselves. But they are all busy and just maybe not as good as we are. Honestly, the work we get usually are the ones we could do faster and cheaper than they can. That is the reason we are always honing our detailing abilities to keep in step with these expectations, faster and cheaper. We have always met these expectations. The rebar market in the United States. There are 2 distinct markets, FOB market and the installed market. In the FOB market, the fabricator sells the rebar delivered to the job site only. They do not have anything to do with placing nor installing the rebar. Their only concern is the detailing be strictly according to the drawings. In the installed market, the fabricator and the installer or the ironworkers are one and the same. The sale is not complete until the rebar are installed. This is the map of the United States. In the west is the Pacific Ocean, the east, the Atlantic Ocean, and the south, Mexico, and the Gulf of Mexico. Over on the north side is Canada. All along the west coast here, California, Oregon, Washington, part of Nevada, and part of Arizona are installed market. All the other states are FOB market. The western region, most of them, the mountain region, and the eastern region, according to CRSI, are mostly FOB market. In an FOB market, the detailer details rebar exactly as shown and does not concern himself in a large degree with the placing of rebar. Most of the time, standees, spreaders, and template ties are not part of the job. When stirrups are shown close, they are detailed close. Detailing is done exactly as shown in the contract drawings. Remember that. Detailing is done exactly as shown on the contract drawings. However, in the installed market, detailers scrutinize the design, anticipate rebar congestions, and find ways to make the rebar easy to install. They will sometimes sacrifice material to save on placing labor. All standees, spreaders, and template ties are included. Stirrups are made open with caps. It is hard to make an ironworker happy. No two ironworkers are alike. One system that works for one may not work for another. So rebar detailers in the West Coast tend to build a rapport with their ironworkers. Some of them will work very well with certain ironworkers. Bar Lines has a reputation for being iron worker friendly detailers. So the key now is, early on, the detailer should determine whether the job on hand assigned to him is FOB or installed. Where the job came from could be your hint. Anywhere but the West Coast is FOB. There is, of course, always an exemption to the rule. From time to time, certain parts of Texas will have a contract that is installed. But by and large, Texas is FOB. This is the market in the United States. We're now ready to go on to hands-on rebar detailing. Here is a detailing form that we used to use 40 years ago, before the advent of personal computers. All our detailing were all done manually. We will write the descriptive items here, line by line. We will have, you notice there's columns for quantity, sizes, lengths, mark, type of bend, and then the dimensions A, B, C, D, and on and on. We practically, back then, invented all the terms that you see now, like EF, each face, near face, when we're facing a wall and it's a two-curtain wall, the vertical bars closest to us, we call them vertical bars near face, and the vertical bars away from us on the back side, we call that vertical bars far face. So we invented most of those terms, and as I go on and teach you and demonstrate to you how I do rebar detailing a long time ago, I will slowly describe what those terms that we invented. So our style is descriptive. Remember, the drawings are already done by the structural engineers. There is already a placing drawing practically. The only thing it doesn't have is the quantity. It has the size. All it needs is the quantity and the length of the bars, or sometimes the shape of the bar or the bar mark. Our detailing will provide that, but we will utilize the drawings that are already done. We will call on them. For example, a good example is whenever we're doing column pads, here's what you will see. I will say column pads. I will call out the detail on the drawing 2 on S5.01. This is the contract drawing. And I'll say the first pad, mark 1. I have 2 sets of those. I say 2, and then I draw a line that denotes dittos or same. I will describe the bar. I will say mat, hop each way, bottom. And I'll say I have 28, number 8, 12 to 10, which means 14 goes one way, the other 14 goes the other way. I said that, hop each way. Or here I could say 14 each way. But sometimes saying half, I could use this here and here again by just copying this. So when the computer came, it made it easier because now we could just highlight all 4 of these lines and copy it. Because half will work whether it's 14, like in this case 11, or in this case only 11. So I say mat half its way bottom. And then I say column dowels 7-2. 7-2. What does it mean? 7. There are 7 vertical bars on the north and south face. And there are 2 intermediate bars on the east and west face. That's what it means. So without me drawing it, I practically have an orientation of a column with 7 bars on the north and south and 2 intermediate bars on the east and west. Then I will have the next line, template ties. I have 3 of them, number 4, and here are the dimensions. The length is 6'5", the mark is 482, boom, boom, boom. Then another template tie. This is the intermediate tie inside. Then I'll continue on. Mark 2. I have 3 of those. And then I'll continue on. 3. This is how we do things. Very descriptive. Do I need to make a drawing for this? No, it's just a column mat. Do I need to say what the size of the pad is, the concrete size of the pad? No, because by the time my rebar comes to the job site, the 12'6" hole is already dug. The mat is 12'6" by 12'6". So my bars 12 foot will fit right inside it. And by looking at 2S501, the iron workers will know that these are all the bars he needs for that one. Mark 1. The mat rebar, the column dowels, and the template. And he already know how to install them, how to put the rebar cage on the column dowels. 7-2, 7 bars on the north and south face of the column, 2 on the east and west face. So by doing that, I don't need to make a drawing. That's it. So this is how we make use of this form sheet. The detailers and the iron workers understand each other based on certain terms that both of us agreed on. Our joint collaboration practically invented those terms. The detailers and iron workers greatly utilize the contract drawing as their placing drawing. The detailer very seldom draws a placing drawing. If it's not covered on the contract drawings, that is about the only time a detailer will make a sketch. As you learn to use Shear 97 detailing software, you will find similarities between this form and Shear 97. Most of the detailing software are based on this form. This is how it all began. Doing detailing a long time ago, before computer, before calculators, handheld calculators, we used to use slide rule. And we learn, because we're dealing in imperial, we learn to calculate everything in decimal of a foot. We practically memorize the equivalent decimal of a foot. 1 inch, we already know, 0.08. I still remember it. 2 inch is 0.17. 3 inch is 0.25. So now if I'm adding 3 inches, I add 0.25 plus 0.25, it comes up with 0.5, which is a 6 inch. See, all the rebar detailers then memorize this in their head. Now that we're using calculators, I still use them immediately. Rather than say 6 inch plus 6 inch divided by 12 to get the foot, already by just adding, using the decimal equivalent of a foot, I got my answer right away. So these are some of the things we invented then. And now, and showing this to you, we're now going to go through the detailing of a foundation. But before we do that though, I also like to show you my preparations when I begin a job. This is a set of contract drawings. This particular job is the March Air Force Base Control Tower. When I begin my work, first I study the scope of work. I read through that. I read through the specs, and I determine whether the job is FOB or installed. Then I read the drawings completely from page to page. I go through it one until I can build it in my head. I imagine building it in my head. I begin from like I'm building it. I go from the very bottom of the structure and slowly going up and up until I practically build the whole thing. And it's time that I'm picturing it, where the walls are, where all the foundations are. Is there going to be a concrete wall? Is there going to be a masonry wall? Are the roof concrete, or is anything concrete? Is the floor concrete? Is it slab on metal decks? I picture all that. I go to the architectural drawings. I go to the mechanical drawings, plumbing, electrical. Are there any holes in the mechanical that will affect my rebar detailing? Supposing a pipe goes through a wall, what happens to my vertical? Do I need trim bars and all that? So nowadays, sometimes I play around with making, I don't know if you guys have seen SketchUp. Those who are architects will know about SketchUp. I will draw it in SketchUp, and I'll picture it. I'll do a 3D, and as I'm developing my detailing, I slowly develop my 3D, so I know how it's going up. And then when I'm done, I could visualize my 3D. I could see my 3D. I could move around my 3D. I could see if I had done a good job or not. These are the things I do. So once I got this in my head and I want to go to the details itself, then I check on the following. I check on concrete specs. What are the concrete specs on this job? I see it. They're saying in this job, okay, let's look it up, and it's, oops, and it's saying the foundation is 4,000 psi, the slab on grade is 4,000 psi, walls are 4,000 psi, and the slab on metal decks are 4,000 psi. So I'm only got one strength, 4,000 psi. I need the strength to determine my lap splices, because lap splices are a factor of the strength of the concrete also. Then I look at, is it all normal weight? Because if it's lightweight, then I have to apply a certain factor to the splices. Then I check the ASTM specs. You remember the ASTM specs? It's important. We need to know what the specs is. So I look and I read through the general notes until I find them. In here, it's saying material, reinforcing bars, ASTM, A615, grade 60. And it's saying 3 bars may be grade 40. So if I like to, I'll say, okay, all the number 3s are grade 40, the rest are grade 60. If the bars are going to be welded, they want A706. The welded wire fabric is a standard, ASTM 185. So, and they're saying, detailing, fabrication, and placing shall be according to ACI 315 and 318. I look, and then I check on protection, concrete clearances, cast against or exposed to earth 3 inches. In other words, all my foundation, if the rebar is going to be laid on earth, I have to be away from dirt 3 inches. If it's going to be exposed to weather, it's formed, but once they remove the form, it's exposed to weather. It has to have a clearance of 2 inches. Not exposed to weather, for example, underneath of the slab, or inside of a wall, inside base of a wall, 3/4 inch. Beams and columns, to the stirrups, not to the main steel, but to the stirrup or ties. It's 1.5 inches. See, these are what I need to do. And as I gather them, I copy them in a piece of paper, all this information, and I tape them in front of me in my detailing station. So that's why our detailing station has 3 side walls. You have walls so you could stick these items in. So you don't need to flip to the drawings. You look in front of you. Every time you're detailing, get a piece of paper and put the name of the job, and here are all the items I need. That way it's easy for you to look at. Okay. So I go through all the motion of all this until I get all the information I need. I check whether there's rust protection. Are the rebars going to be epoxy coated or galvanized? And I check the lap schedule. See if there's a lap schedule. If there's a lap schedule, I copy that lap schedule. And I look for other requirements for laps. Like in this case, there is a special requirement for lap. Let's see what this is. Let me enlarge it. It's got this special note. It says, spacing, clear distance between parallel reinforcement and layers shall not be less than 1.5 times the nominal diameter. So it's got that thing. Splices, like this one. Splices, let's highlight this. Splices, you have to use Class B lap splices. Lap splices per bar splice schedule, stagger bottom splices. So there's a requirement of staggering them. You cannot have splices all at the same point, so you have to stagger them. So if you have a series of bar, make sure your last bar and your beginning bar and your last bar are not the same. This way they could stagger them by flipping the ends on each side. You could stagger bars, a series of bars, by alternating ends. You put one end on one side, and next time you put that side on the other end. But make sure the end bars are not the same. If you make them the same, they won't be able to stagger anything. Concrete block. I check it out and I see. I look for something like open or close end blocks, and I will explain this later on when we're doing the masonry wall detailing. So anything that is pertinent to my detailing, I gather them, I put them in a piece of paper, and I put them on the board, on the walls that I next around me, facing me, most of them. This is how I do my preparations. The lap splice schedule on this particular job shows 2 categories: top splice and other splice. Top and other. The top only pertains to horizontal bars, not vertical bars, just horizontal bars with 12 inches of concrete underneath it. Others apply to vertical bars and also horizontal bars that doesn't have 12 inches of concrete underneath the bar. So that's the difference. A detailer should know this very clearly. We have a video that explains this. We are now into the specifics of detailing foundations. We begin, of course, with the first item of foundation. Usually it's the the deepest concrete. It is usually the drilled piers or caissons if they are present in the job. Then you climb up one item at a time into column pads or pile caps, then into grade beams or tie beams, and then and sometimes you have to go into a mat foundation. All of these are foundation work. Slab on grade is part and parcel of the foundation work also. So we begin with the caissons, and I will demonstrate to you the way I used to do caissons using the manual descriptive detailing style that we used to do 40 years ago. Here's how I used to do caissons 40 years ago using descriptive detailing on a form sheet like this. Everything is done manually. I reference the detail on the caissons using the contract drawings, in this case A-S1, that's the actual contract drawings. And I use the same markings on those caissons or drilled piers, P1, P2, P3. If I have a series of P1 and some are different than others, I will distinguish them by putting a subscript, P1A, P1B, P1C. But they're all still all P1 based on the contract drawings. I will not or never will change the markings on the contract drawings. That will just confuse everybody. So I will use the same marking. Mine might have a subscript, however, might have P1A, P1B, or P2, P2A, and so on. In caissons, the items are usually a vertical bar, maybe a vertical dowel, and ties, spirals, or hoops. And sometimes I will supplement my detailing with a drawing. But first and foremost, I finish all my detailing first. I gather all my P1, get all those items like lengths and all that. And I'll put verts, which means the vertical bars. I have 20 of those P1s. I'll put 20. Underneath I will do a double line which denotes 0, which means this next line is also 20. I will put on a quantity. In this particular case there's only 4 vertical bars. Number 7, I do not know the length yet, and I will put the bar mark 7 as the size of the bar. C is what I chose to as my letter for this entire release, 7C01. And then the type, it's a type T2, it's a right angle bend. Standard bends 1.2, 13.3. A long time ago, and still now, the detailers used to remember all the bend types. So, and if we forgot, we could always look at our table. So in this case, a number sense 90-degree bend is 1.2, the vertical leg is 13.3, so I have a 14.5. I add these two to get the length. The ties, I found number 12, they're all number 3, and I have all these dimensions. If I will show you the drawings that I had for this particular one, shows I have 4 vertical bars and a tie. Looking at the tie, you will be tempted to use a type T1, which is a square tie, because there's 4, it's really a square tie. But that's not what I use. I use a type T4. T4, if you look at your standard bend, is a diamond tie. T4 is a diamond. We use a diamond because we don't really know the BCDE. The BCDE is rounding up at the corner. It's not equivalent to the hypotenuse of the height and base. Sometimes detailer, because they know the height and base are the same, they tend to assume it's a type T1 and they use the hypotenuse. Look what happens if you use the hypotenuse as your B, C, D dimension. if you happen to use BCD dimension, which is the heavy lines inside, see, your clearance is 1.5 in this case. You see that point to this point, that would be your hypotenuse of this base and height. But you notice it's narrower than the actual BC and D. The actual BC and D, because it's rounding up at the corner, enlarges the bar. So the actual tie is about 2 bar diameters wider. We had a detailer, a smart detailer from USD, who had several caissons, like something 30, with 4 number 8 bars vertical. He made a mistake using a type T1 for the ties, and because he's a smart kid, he right away said, "Oh, I know the base, I know the height, I can use the hypotenuse." So the BCD is the hypotenuse. It was too narrow. They weren't able to use it. We had to buy a new set of ties for all of those piles. Because it's not a type T1, it's actually a type T4. Remember that. It's a diamond tie. A diamond could be looking like a square. But there are occasions where if you use it on a rectangular column, a diamond would be looking like a diamond, not like a square. So going back to my detailing, even then, I was smart enough to not know that I could not use a type T1, I have to use a type T4. So the other thing I recognized at that time is to make it easier for my iron workers, I need to show them where to begin those ties. I need to tell them exactly where to begin spacing. So on my drawing I said, begin the first tie 6 inches from the end of the vertical bar, and then spacing, and so on. I did this because I recognized that concrete is not available to them, and I should not be referencing the concrete, because like columns, caissons are built using horses like this. So they put the horizontal bars on horses, and then they hang all the ties, and they insert some more vertical bars, and then they begin to tie all of them. So they begin to assemble them into cages way out of the hole where it's going to be dropped. So in a certain part of the job site, guys are busy building them into cages. So do not be referencing concrete, because the concrete is nowhere in sight. Reference the end of the bar. This is true on caissons and columns. It's built on horses. Okay, to continue on. Then I have type 2, I have 22, that's column pad. Where's my, there. I have a Mark P2 caissons. The birch is number 8, 29'6". It's a straight bar, and at the top it's got a dowel, 8 number 8, 8CO3, type 2, 1.4 by 5.9. It's a dowel. It's like this. It's got a vertical bar and dowel at the top. And then I have a spiral. A spiral is written a long time ago like this, and it's still written like this. But you now have some tools to help you. While before we didn't. I put a bar mark on it. I use this sequence that is already available. I never start a sequence again just because I have a different size bar. If I do that, I'll have a hard time of keeping track of where I am. By doing this, just going by sequence, 7C1, CO2, CO3, 4CO4. The first dimension I need, which is the A dimension, is the height of the spiral, from the bottom of the spiral to the top of the spiral. The second dimension I need is the diameter of the spiral out to out, in this case 2 feet, because the caisson is 2'6", 3 inches clearance on each side gives me 2 feet. The third dimension I need is the pitch or the spacing, 6 inches. The last dimension I need is not really a dimension but a count. It's the number of turns. Okay, let's go back. A spiral has to have 1.5 turns at the top and bottom, 1.5 turns each end. So 1 full turn and a half. So that's 1.5 turn here, 1.5 turn there, means 3 turns. So to get my number of turns, the height divided by the pitch, 6, gives me the number of turns, plus I add 1.5 on top, 1.5 to bottom, plus 3 inches. I came up with 62 turns. To find out the length, I find the circumference of the 2-foot diameter, and that would be my base. In this case, my base, like that. And then the pitch would be my height. The circumference, the hypotenuse, the hypotenuse that it creates, base and height, is the actual length per turn. So now that I have the length per turn, I multiply that against the number of turns, 62, and I come up with 390 feet and 9 inches as the total length of the spiral. That's how we used to calculate them. But nowadays, this is automatically done on your detailing software. All you have to do is enter all this, boom, it gives that to you. So it's a lot easier now. Then I have Mark P3, which is the same thing, vertical bar and a dowel, but this time they're using hoops. The hoops is a type T3. So hoops is just type 3. That's easy. The length is the circumference plus the lap, 2 feet. That would be the thing. And you get the number of bars by dividing the height by the spacing. That's how I come up with that. Okay. When detailing caissons, keep a lookout for places where they may need to use temporary shells. Temporary shells or casings. I think I made a drawing for that. Sometimes they put a temporary casing around the caissons to protect it from dirt caving in and into the concrete, caving in into the hole. Sometimes the dirt, that's why they have caissons, is the dirt is very poor and it's loose. So if they do not have these temporary shell casings, then dirt could fall in and mix with the concrete or remove the holes they already dug, they already drilled. In cases like that, make sure the dowels is not a 90-degree bend but a 180-degree bend inside, because these temporary casings are temporary. After the concrete is set, they remove it by pulling it up and using it over again. They use it over and over again. Sometimes they may have only one casing for the entire job, or maybe 1 or 2 or 3 casings. But they're reused. They're not left there in place. They don't need to. So because of that, make sure your bars at the top is bent inward rather than outward. That's the thing there. One thing you will notice also, when I'm doing my detailing, I leave out the total. A long time ago, 40 years ago, we used to have what we call order writers. We have a bunch of girls in a room, and we give them the order, and the first thing they do is they do the multiplication. They multiply that. And their job is to make tags. The tags are done manually. They have tags. They have several color tags, and they put these all tags. And then they have a pre-dead machine. A pre-dead machine is a manual pre-dead machine, and they do the calculation to find out the weights. And they write the order on a bar list sheet. And then that's what they send to the shop. So we have a bunch of order writers. The order writers now are gone. There are no order writers anymore, because as you're detailing it, you're creating a bar list, you get the dimension, and because it's a computer, digital computer, the files that you create goes to a machine. The machine will spit out the tags, the right number of tags, depending on how much pounds you want a bundle will be. So this done all done automatically. It's much safer now, much. The weights are accurately done. The girls sometimes make mistakes on the weight. That's never happened now. But still, the format that you use will still need to be like this. You group them so that the iron worker will know exactly what set of bars he needs to collect and gather close to P1, what set of bars to P2, what set of bars to P3. You never mix them. And always your multiplier on sets, number of sets, has to be true to a set. 20 set, 15 set, 15. That way he knows immediately how many cages he's talking about. And in my case, because they still do not know which one is going to be temporary shell, I prepare those dowels already. And in the last minute, when they say, oh, P3 is going to have a temporary shell, immediately I could erase this and replace it with HC06. That's how I do it. That's how we do caissons. The next item I'm going to show you is how I do column pads. Again, based on the old style 40 years ago. Same thing as the caisson. Column pads, I call out the section on the drawing, detail 2, in this case S5.01. It shows the detail of column pads. Column pads are pretty easy, and column pads and file caps are somewhat similar. The only difference somewhat is most of the time is column file caps have sometimes bars on top, but otherwise the detailing is fairly the same. Let me call this out. I use the same marks as the drawing that I have, and if I have a series of mark 1 and slightly different configuration, I might add, just like on the caisson, I will add a subscript like 1A, 1B, 1C, but I still maintain the bar marks on the drawing, like bar mark 1, bar mark 2. Changing the bar mark from the drawings will only confuse everyone. And I describe what I have. I've shown this to you before, mat, half each way, as opposed to saying how many bars each way. I would just say half this way. This set of description can be reused over and over again, because half will apply to anything. Like in this case, 28 number 8 12 foot, half of that of course is 14 number 8 12 foot, which means half of this, 28 or 14, will go one way and the other half goes the other way. And then we have column dowels. 7-2, as I mentioned before, will denote the number of dowels, 7 on the north and south face of the column, and 2 intermediate bars on the east and west face. This is a means to orientate the reinforcing. The orientation of the dowels is very important. Sometimes, in this case, you could see that the columns is rectangular. There are more bars on the north-south face than on the east-west face. The bar itself looks like this. 7 bars, 1, 2, 3, 4, 5, 6, 7 on the north, reference north and south face, and 2 intermediate bars on the east and west face. I will not call these bars because I already called that as 7 bars on the north and south face. So on the east-west, I'm only calling the intermediate bars. The ties, the template ties I have is one closed ties encompassing all the bars and another intermediate tie to hold these 6 bars in a certain location, fixed location. It's a dowel, and I need these bars, the ties, to be a template tie. Going back, I will have template ties. There's 3 template ties. They're all number 4. I usually use the same size bars as the actual tie. The template ties are usually not shown on the contract drawings. What is shown is the actual tie, and I will use the same size. And I'll have a type T2. The type shown on drawing will most likely be a type T1, but for template, I'll make it easier for the shop by using type T2. Type T2 has a 90-degree ears rather than 135-degree ears. 135-degree ears might get in the way of the dowels when they're so close together. A type T2 won't have that problem because it's 90-degree. So because it's just a template tie, I sometimes will use a type T2. I could use type T1, there's no problem with that, but I'm so used to helping the shop because T2 is easier to bend than the type T1s. And then my intermediate will be the same, but the different dimensions. A column pad is like this. You have a box, you have a mat, so many bars one way, so many bars the other way, and the column. These are columns. The columns has to be set in such a way that it doesn't interfere with the actual column cages as it's being hoisted down into the top of the concrete. So the configuration of the dowels are like this. They're set inside in a concentric manner from the actual position of the vertical bars. It's inside. And a template tie is used to hold it in place. Without a template tie, the ironworker will have a hard time placing those bars. The template tie, one at the bottom, one immediately below the top of the concrete, and another one to hold the top. This top one sometimes are taken out before they hoist the column verticals. If you have those template ties at the top, you won't be able to hoist it down because the ears of the ties will get in the way. So here the template ties has 135-degree hook. I could make them T2 by making them 90. The dimension of the template tie is based on the distance of these corner bars. The corner bars, they're all the bars are made the same way. You notice that the corner bars has more H dimension, which is the offset dimension if you've got detailing the column, than the inside ones. The inside one is only very short H dimension, while here it's long H dimension. So when I'm detailing this, I use this and then I lay out my template tie. You know, with the 3D, with the CAD now, you could easily figure this out. But what I do, I deduct 3 inches from the size of the regular tie as my dimension for my template tie. I find that 3 inches will practically take care of all dowels from number 6 to number 11 bars. You may want to check that out, but every time I have a template tie, I figure out what the actual tie is and I deduct 3 inches. That's my template tie. I have one at the very bottom, not quite at the bottom because of the bend of the dowels, as far as it will go, and then one just below the top of the concrete, and then another one on top. My height for the dowel is depth minus 3 inches, which is 3 inches is the clearance from the rebar to the dirt. I use that as D minus 3 plus lap is my length, when actually the bar is sitting on top of a mat. So my clearance really to the dowel is greater than 3 inches. But I need those extra bar, extra inches just as an allowance for my lap. My lap, which is calculated to be L, will be actually greater than L because I will have the two diameters of a bar to add to it. So this is what I use. You could be exacting, but you don't need to. It's better to have a little bit of dimension on your dowel. Remember the tolerance for bent bars. You could detail it correctly and the bars will come to the job site 1 inch less and the shop is covered, but you don't have enough lap. So by calculating the total height to be lap plus D dimension minus 3 will give you extra lap length. That's my way anyway. And again, the spacing of the bars is from the Manual of Standard Practice. I use that, if you remember. And this is how it shows. And I always have, you could send 2 template ties or you could send 3. I have a habit of 3 because I know 2 will be inside the concrete and 1 will be outside. And this outside one is thrown away. The clearance of the template tie is just like so. You have enough space between vertical bars and vertical bars, and that would be the proper size of your template. So column pads are easy. Pile caps is somewhat the same. On mark number 2 pads, I have the same thing, mat half each way, the dowels, and then I say also 7-2, 5-2, which means 5 on the north and south face, 2 intermediate, and this is it. So about the only thing you need to know about column pads is you need column dowels and the template tie. Okay. When this is a pile cap with the top layer of mat reinforcing, do not forget to use standee to support the top mat. The standee could be type 25 standee, which is like this. It's actually bent in one plane and then they spread it at the job site. To get the height, all you have to do is provide the eighths and it will calculate the actual dimension. You should have enough dimension here for bars to be tied to. If you round it up, the bars might fall off. So you need to have a little bit of a straight edge. And make sure the base of your standee is enough to go over 2 transverse bars. If you only had it one, it will fall off. It has to be laid on top of 2 bars. So 2 bars here, 2 bars on that leg, and 2 bars on this leg. This is a type 25. There's another type, but this is most common for column pads. If the column pads got tie beams that will be later poured in between them, do not forget to include the dowels. Remember, All bars belonging to the column pad when it's poured has to be included with the column pad. You cannot detail these dowels with the tie beam because the column pad will be poured first. Whoever gets poured first, anything inside it must belong to it. So when you're detailing the column pad, you have the mat, you have the dowels, and you have the dowels also for the tie beams. Do not forget the tie beams. Do not detail them separately. Has to be detailed together. So here, if I had that condition, I will have another line that says tie beam dowels. Okay. That's for this. The other thing, if you're detailing column pads and there are column pads, you're detailing column pads, that's all you're detailing, column pads. The column pads was usually thicker than continuous puttings. The continuous puttings are usually shallower. Okay. Do not forget to include in your column pads those dowels that are going to be poured with it. In the event that they pour the column pads first before the continuous putting, the dowels are already in the column pad. So now you will, in my detailing, remember that I will add for the tie beam dowels and another line for wall dowels, set a few quantities of wall dowels on each side to take care of wall dowels when the situation is like this. Normally though, continuous pourings and column pads are all poured together. And if they are, you could detail those dowels with the continuous pourings as long as they go to the job site the same day. However, let me caution you, when you're detailing the dowels, those dowels are not the same. One is longer than the other. Remember, the bars, these two bars here, will be longer because the column pads are deeper than the continuous putting. Take that into consideration. If you don't, your detailing is no good. See how simple a column pads is, but it becomes intricate when you're thinking of template ties, when you're thinking of standees, when you're thinking of tie beams, and when you're thinking of walls. All of this has to be taught together because they're all part of the job. And the rule is, anything that goes and inside the column pads or pile cap has to be included in the set. Cannot be separated from the set. That is the rule of the jungle. This might be a good time to make a break because this video should be pretty close to an hour now. The next lesson will deal with grade beams, tie beams, continuous puttings, maybe slab on grade, and so on. Thank you very much. I hope you learned something.